Ever looked in the mirror and thought, whoa, where'd all these atoms come from?
Yeah, it's pretty wild when you think about it.
Well, buckle up, because today we're going deep, deep into the mind-blowing world of stardust.
We are literally made of exploded stars.
It's true. And to unpack all this cosmic awesomeness, we're diving into excerpts from a book called Dead Stars and Heavy Elements: How Exploding Corpses Built You.
Catchy title, right?
It definitely grabs your attention. Okay, so think back to the very beginning of the universe, right?
Back to the Big Bang.
Exactly. It was mostly just a sea of simple elements.
A lot of hydrogen, some helium, a little bit of lithium.
Not exactly the stuff that planets or, life is made of.
Pretty basic ingredients for a universe.
But here's the thing. Everything we see around us today, including you and me, was forged in the fiery depths of stars.
We're talking about the heavier elements, the gold, iron, carbon, all of it.
The building blocks of life itself came from exploding stars. Intrigued?
I hope so. This is where it gets really interesting.
So let's break it down. Stars, they're kind of like giant cosmic kitchens, I think.
We like that analogy.
They're constantly cooking up new elements.
They're more like giant nuclear reactors, really.
But instead of energy, they're creating, well, everything.
Exactly. It all starts with the simplest element, hydrogen.
And through intense heat and pressure, stars fuse those hydrogen atoms together.
They smash them together to create helium.
It's like squeezing two tiny drops of water together until they become one bigger drop.
But in a much, much grander scale, and with atoms, not water, obviously.
So this fusion process, it's happening all the time in stars all over the universe.
Constantly, every second. Stars are busy fusing hydrogen into helium, releasing incredible amounts of energy along the way.
But the cosmic cooking doesn't stop there, does it?
Oh no, it goes way beyond just helium.
So then those helium atoms fuse to form
carbon, and then carbon fuses to form oxygen.
It's like a chain reaction of creation, just building up the periodic table one atom at a time.
It's a pretty remarkable process.
Amazing. But,
Yeah.
Okay, our source material also mentions these things called supernovae.
Yes, supernovae.
What role do they play in this whole stardust story?
Well, this fusion process, it has its limits.
Limits.
Stars can only create elements up to iron through fusion.
So to get the heavier elements, we need something even more dramatic.
We need something more explosive.
Enter supernovae.
The grand finale for some stars.
So these stars, after spending billions of years creating elements, they just explode.
Exactly. They run out of fuel and can no longer support themselves against their own gravity.
Like a cosmic balancing act that goes wrong.
You could say that. The core collapses and boom.
A supernova.
A supernova. A spectacular explosion that blasts all those newly formed elements out into space.
Including those heavier elements, the ones beyond iron on the periodic table.
All of them. Scatter across the universe.
Wow. So that gold necklace someone might be wearing, that's literally stardust from a supernova explosion billions of years ago.
Isn't that incredible?
Talk about adding some sparkle to your jewelry.
But wait, there's more to the Stardust story. There's another chapter that takes us to even more extreme environments. Neutron stars.
Neutron stars, our source mentioned those. They sound intense.
Intense is an understatement.
How intense are we talking here?
Imagine an object so dense that a teaspoonful of its material would weigh billions of tons.
Whoa.
That's a neutron star, the collapsed core of a massive star squeezed into a tiny, tiny space.
And when two of these incredibly dense objects collide,
Let's just say it makes a supernova look like a firecracker.
more powerful than a supernova.
Oh yeah, much more. The energy released in a neutron star collision is mind-bogglingly huge.
So it's in these cosmic crashes that the heaviest elements like gold, platinum, uranium.
Are forged.
So not all gold comes from supernovae. Some of it comes from these neutron star smash-ups.
It does.
Wow. This whole concept of stardust is just, wow. But let's bring things back down to Earth for a second. What about the elements that make up our own bodies?
Excellent question. We've been talking about elements scattered across the universe, but what about the ones right here with us?
Right here in our bodies.
Well, the most common heavy element in your body, the one essential for life itself, also comes from those long-dead stars. Any guesses?
If we're talking heavy elements from stars, I'm going to go with iron.
You got it.
Iron.
Iron. And it's no coincidence that iron is so abundant in our bodies. It plays a crucial role in keeping us alive.
So we've got these supernova explosions and neutron star collisions, creating all these elements, scattering them across the universe.
Like cosmic fireworks.
But how does that iron actually end up in our bodies? I mean, how do we go from exploded star to, well, me?
Well, After a supernova or a neutron star merger, all those elements get blasted out into space.
Right, like a giant cosmic mess.
Exactly. They become part of these huge clouds of gas and dust.
And those clouds are just filled with the building blocks of life.
And over time, gravity does its thing, pulling those clouds together
To form new stars.
New stars and, you guessed it, planets.
So our solar system, our planet, even us, we're all formed from the recycled remnants of ancient stars.
That's right. It's like the universe has this massive recycling program going on.
So the atoms in my body have been on this incredible journey.
They've been through stars, supernovae, interstellar clouds, all before becoming part of you. Billions of years in the making.
And one of the most important elements in that whole process is iron, right?
Definitely.
You said it's crucial for life. Why is that? What makes iron so special?
Well, think about what happens every time you take a breath.
I inhale oxygen.
Right, you inhale oxygen, and that oxygen needs to be transported throughout your body to all your cells.
Okay, so that's where the iron comes in.
You got it. Iron is a key component of hemoglobin.
Hemoglobin.
It's a protein in our red blood cells, and it acts like a little oxygen shuttle.
So we can thank a long-dead star for every breath we take.
Pretty much.
Oh.
Without iron, there'd be no efficient way to transport oxygen around our bodies. Complex life as we know it wouldn't exist.
It's amazing how it all comes together.
It is. And it's not just iron either. Think about all the other elements in your body.
Carbon, oxygen, nitrogen.
Calcium.
They all came from stars.
Every single one.
Wow. It's mind-blowing to think that every atom in our bodies has this epic, cosmic backstory. It makes you feel connected to the universe on a whole new level.
Absolutely. It's a powerful realization. But let's imagine for a moment that stars didn't create those heavier elements.
Okay, I'm picturing it.
What if the universe was just hydrogen and helium? Nothing else.
I think it would be a pretty boring place, wouldn't it?
Mm-hmm.
No planets, no life, no us, just gas.
Exactly. No complexity, no life as we know it. Just a vast, empty sea of simple gases.
That's a pretty bleak picture.
Yeah.
It really makes you appreciate those hard-working stars creating all that stardust. Speaking of elements with a pretty cool history, our source material mentioned a diamond ring.
Oh yeah, diamonds.
Now, a lot of people think diamonds come directly from space, but that's not quite true, is it?
No, that's a common misconception.
So where do they come from?
While the carbon in a diamond ultimately came from a star, diamonds themselves are formed right here on Earth.
Oh, so they're made on Earth.
They are. Deep beneath the Earth's surface, where the heat and pressure are intense enough to transform carbon into those sparkly gems.
So no magical star diamond connection.
Not directly, no.
But the carbon itself is still ancient stardust.
Absolutely.
Okay, that's still pretty cool.
It is. It really highlights the fact that even seemingly ordinary things on Earth have an extraordinary cosmic origin. Our home is Earth, but our roots are out there in the stars.
Our origins lie in those long-dead stars that lived and died billions of years ago. This whole deep dive has been mind-blowing. It's incredible to think that we are literally stardust, a collection of atoms forged in the hearts of ancient stars.
It is pretty poetic when you think about it. We're not just observing the universe. We're part of it. We're made from it.
And knowing that, knowing you are made of stardust.
What will you do with your time in the universe?
What legacy will your stardust leave behind?
It's something to think about.
Makes you really stop and think.
Yeah, it does.
We're not just looking at the universe from the outside.
We are the universe.
We're made from it.
Yeah.
Our bodies are like living proof of these incredible events that have been happening for billions of years.
It really is both humbling and awe-inspiring at the same time.
It is. And I think understanding this connection to the cosmos, it makes you feel a sense of responsibility too.
Right, like we're all part of this grand cosmic story.
And everything we do, even the smallest actions, they have an impact.
Maybe a tiny impact, but an impact nonetheless.
It's not just about knowing where we came from. It's about realizing what we do with that knowledge.
What we do with this precious stardust that makes us who we are.
It's quite a thought.
Who knows? Maybe billions of years from now, the very atoms that make up our bodies could be part of new stars, new planets.
Or even new life, somewhere out there.
It's a beautiful cycle, isn't it? Creation and transformation over and over again.
The cosmic dance never ends.
It really doesn't.
Well, That brings us to the end of our deep dive into the incredible world of stardust.
A truly fascinating journey.
We hope you enjoyed exploring it with us.
And remember, the next time you look up at the stars, you're not just gazing at distant points of light.
You're looking at your own origins.
You are stardust.
And that is something truly remarkable. Until next time, keep exploring, keep wondering, and keep looking up.